Hi guys, thanks for joining me again. This is the Renegade Mathematician, following up on our last video discussing more properties of determinants, and this time we've got theorem 1.47. And it states, the value of a determinant is not changed by adding a multiple of one column to another column. So, here's a proof of that property. Okay, given determinant D, multiply all entries in the kth column by some constant lambda, and add the resulting entries to the corresponding entries in the lth column of D. It looks like 1, but that's an L, because L comes after K. H-I-J-K-L, yeah. Okay, the resulting determinant is D sub L, because we're replacing the lth column. So D sub L of lambda times A sub ik plus A sub IL. So we're replacing the lth column with that linear combination there. Okay. By property 1.44, that is the linearity property, D sub L of lambda sub ik plus, lambda times A sub ik plus A sub IL is equal to lambda times D sub L of A sub ik. That is where we can break it up into a linear combination of determinants where we replace the lth column with A sub ik and then also A sub il. So we're using property 1.44 to break it up. Since D sub L of A sub ik has two columns that are identical, that is the kth and the lth, then by the corollary to property 1.41 and 1.42, it equals 0, right? Because a determinant that has two identical rows or columns is 0. So that one goes away. Furthermore, D sub L of A sub il is D with the lth column of D replaced with the lth column of D. That is, it's D sub L of I sub il is just a convoluted way of expressing the original determinant. So that is just D. So, thus, D sub L of lambda times A sub ik plus A sub il is equal to lambda times D sub L of A sub ik plus D sub L of A sub il, which is equal to lambda times 0, right, because that determinant has two identical columns, plus D, the original determinant, which is equal to D. So, QED, what have we done? We have taken one column, multiplied it by a number, and added it to another column, and it didn't change the determinant at all. It's the same. It's the same determinant, D. So, this property is usually used when doing row reduction, which is much more common than working with the columns. So, of course, the property applies to rows as well as columns. But generally, you'll use this property with columns. But in case you still don't know what I'm talking about, here's what I'm talking about. So on the right, we have this determinant, the original determinant D. And what we've done is we've taken lambda times column K and added it to column L. And then to the left we have the result, where we've taken a multiple of column L and added it, or rather a multiple of column K and added it to column L. The result is the same, right? The original determinant is the same as the resulting determinant when you add a multiple of one column to another one. Makes no difference. Okay, so that's it for this video. I hope you enjoyed it, and we'll see you next time.